Hello class and fellow mathematicians. Here we go. We're going to take some notes and we're going to focus in a little bit more on decimals. Please put your name at the top of your paper. And also, I think it would be helpful if you circled that this paper is notes. So that means it's important and it's a nice reference for you to look things up. All right, first thing we're going to talk about is comparing and ordering decimals. So let's read along. Remember, this alligator symbol here means is less than, and the other alligator symbol pointing the opposite direction means is greater than. Also, a tip, you can use a number line to compare and order decimals. Alright, we're going to complete the statement using is less than, is greater than, or equals. What I think is helpful when you're comparing decimals is to make sure that they have the same number of decimal places. So the same number of digits to the right of the decimal. Alright, so our first example, number 1, the first decimal number has 3 decimal places, 3 digits to the right of the decimal. 0.543. Now we're comparing that to 0.54. Let's make sure that has 3 digits to the right of the decimal. So 0.5, 4, and let's add a 0, which is perfectly legal. Now it's easy to compare. Kind of just ignore the decimal and think of this as 543, and this one is 540. Well, 543 is greater than, so we'll use the is greater than symbol. Alright, looking at number 2. This goes to the hundredths place, and so does this one. So they have the same number of decimal places, same number of digits to the right of the decimal. So we can compare. When I compare, I just ignore the decimal. 103 compared to 130, well, 103 is less. So once I have the same exact number of digits to the right of the decimal, then I can kind of just ignore the decimal point. Alright, number 3. These two do not have the same number of digits. This one has 1, 2, 3, 4 digits to the right of the decimal. This one only has 3. So we need to add a 0 onto this one. 0.4250. Well, look, that's exactly the same. They're exactly the same, so we'll fill that in with an equals. Alright, last one. This has 2 digits to the right of the decimal. So does this one. So we can just compare them. Right now we don't have to add in any zeros. When I compare, I kind of ignore the decimal. And so this is 68 compared to 62. And 68 is greater than. Alright, we have one more problem to do here. We're going to order these numbers from least to greatest. Again, I think it's really helpful to have the same number of decimal places. So the same number of digits to the right of the decimal. This has 1 digit to the right. This has 1. This number here has 2. This doesn't have any. This decimal number has 2 decimal places. And so does this one. So let's make them all have 2. So here we go. 5.1. Let's write that as 5.10. The next is 5.2. Let's think of that as 5.20. 20, sorry. The next one is all set, so 5.05. And then just plain old 5, so we have to make that 5.00. And then we have 5.12. And then 5.15. Okay, so now they all have the same number of digits to the right of the decimal point. They all go to the hundredths place. So now just kind of ignore the decimal and put these in order. So think of this as 510, 520, 505, 500, 512, 515. 500 is the least. So we're going to start with that. Let's write this answer in blue. So 5.00 would be first, then 505, so 5.05, then 510, so 5.10. Again, now that they have identical number of digits to the right of the decimal, they all go to the hundredths place, I can just kind of ignore the decimal and treat them like regular whole numbers. Next will be 5.12, then 5.15, and last 5.20. Alright, I hope this is helpful. We'll continue and learn about multiplying decimals in the next segment.